How do people live in space? One major factor is making sure everything is just right, including the temperature. People have lived on board the International Space Station continuously for over 20 years, something that is made possible through its cooling system. Liquid ammonia in specialized pipes throughout station acts as a coolant to keep the temperature habitable for humans. Every so often, the pipes will spring a small leak, and the ammonia escapes outside the ISS. Occasional leaks are expected and typically pose no threat to astronauts, but they're inefficient, could become a bigger problem if left unattended, and can be a hassle for astronauts to manually locate the leaks via spacewalk.
The ISS program recognized very early on that ammonia leaks could be a big problem, and with the large radiators, that they would be something that happened, every couple of years. What they would do is basically monitor pressure in gas lines in various parts of the system, and using those measurements, they're able to isolate a leak to some segment of the overall system. But they don't have the capability without RELL of pinpointing where the leak is.
RELL, the Robotic External Leak Locator, a toaster oven-sized tool that can detect ammonia leaks outside of station. RELL can locate an ammonia leak in a fraction of the time required for a manual search. Deployed by station's robotic arm, RELL uses two instruments and plays a game of hot and cold.
The RELL, it's a tool that includes a mass spectrometer and a total pressure gauge. So a pressure gauge is pretty straightforward. It just tells you the local pressure where it's pointed, and pressure is equal to the number of molecules that are there. The mass spectrometer is a little bit more complex. It not only tells you how much gas is leaking out, but it also tells you what that gas is.
Using these instruments, RELL is able to detect the gases in its surroundings and follows the trail of ammonia until it finds the highest concentration, thus revealing where the coolant system has sprung a leak. Following the success of the first RELL tool, launched in 2015, a second was launched in 2019. The RELL tools were initially stored inside of station, which meant a lengthy and precise procedure to get them from storage out of the GEM airlock, picked up by Dexter for leak locating, and finally returned to the airlock. That's where RiTS comes in. The Robotic Tool Stowage, or RiTS, acts like a garage or robot hotel. It is affixed to the outside of station and has two ports for each of the RELL tools to reside while not in use.
The RiTS was launched in December of 2019, so it's been up on space station almost a year now. It was just kept in storage. It launched up in a kind of a foam box, and it was brought inside the space station. And just in July, the astronauts unpacked it and they installed the leak locator tools inside it, and they got it ready. And then there was an EVA, the spacewalk was performed to install it on the outside of space station.
RiTS and RELL are just another example of how robots and astronauts can work together to enable a sustained human presence in space. Robotic tools are easy to use, efficient, cost-effective, and safe.
One thing I want to note is that the robotic servicing is all done by controllers on the ground. So having the tools outside, we don't need to involve the astronauts on the space station at all. It kind of saves them time, one less thing they have to worry about.
While the RELL units, stored cozily in RiTS, are utilized to keep astronauts safe on station, our team continues to develop and build on this technology on the ground.
So one thing I'm excited about as far as the RiTS technology is, and this has kind of been an evolution of tool stowage designs that we've built. So this is going to be very, very valuable anytime you're going to have robotic servicing, which is going to be increasingly more frequent for exploration in lunar orbit, and also if there's any outposts on the way to Mars, we're going to see increasing amount of robotic servicing, and the robots are going to need specialized tools and ways to secure them safely and keep them protected.
As you can imagine, the ability to characterize the type of gas present and the ability to locate leaks have applications beyond just space station. Anywhere there can be a human habitat, like the Moon or Mars, a leak locating tool will probably be a must. Additionally, robotically characterizing gases in places we've never been before can help us learn more about new environments, laying the groundwork for future exploration.
Always nice to add a new piece of capability to the space station, and there's always a capable group of folks behind it, but this one is particularly special. Dave Parker battling ALS. Wonderful to see a project that he's been involved with from the beginning. To see these lights illuminate. Congratulations, Dave. Congratulations, Team Dave. Team Dave.